Today we're going to look at the properties of a parallelogram. And so the first thing that we're going to talk about is a parallelogram and what that is. Now a parallelogram is a quadrilateral, so that means that it has four sides. And it's special because it has both pairs of opposite sides are parallel. So both sides are parallel. So maybe I have something that looks like this. And now to show that they're parallel, you might see these little symbols. So remember those tick marks where we say that things are congruent? These tick marks with kind of like that look like an arrow show that they're parallel. So those two lines are parallel. And those two are parallel. These are parallel. These are parallel. Now, there's two other things that parallelograms have, and it's that they're opposite sides are congruent, and the opposite angles are congruent. Our sides we're going to show that are congruent with those tick marks, so you might see something like that as well. So that symbol tells us that they're congruent. This symbol tells us that they're parallel. And we could do that same thing here as well. This is parallel, or this is congruent to that. So opposite sides are congruent or the same. And then our opposite angles are going to be congruent as well. Opposite angles are kind of diagonally from each other. So this angle is the same as this angle. And this angle, we'll show that with two little angle symbols in there, is congruent to that angle. Lot going on here. Opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent as well. We're going to find that that helps us really setting us up for, it gives us a lot of information in solving a lot of problems that go along with parallelograms. We also have something else in our parallelograms that we're going to talk about, and we're going to call those consecutive angles. And now consecutive angles are going to be our angles that share a side. And we're talking about interior angles. Angles that share a side. I'm going to draw another parallelogram below here. I'm going to put our little symbols to tell us that it's a parallelogram. Then I'm going to label our vertexes A, B, C, and D. Now, consecutive angles are those angles that share a side. A and D share a side. This angle right here and this angle right here. A and B share a side, so A and B could be consecutive. B and C share a side. And so this angle right here and this angle right here can be consecutive. And then C and D share a side. So this angle and this angle are consecutive. So there's actually 4 sets of consecutive angles in a parallelogram. Now, the consecutive angles are always going to add up to 180 degrees. We can kind of think of it, it looks like a parallel line cut by a transversal. Parallel line cut by a transversal. These would be like same side interior, and so they add up to 180. So our angle relationships that we have are the measure of angle A plus, we'll do B, the measure of angle B. Those two are going to add up to 180 degrees. The measure of angle B plus the measure of angle C equals 180 degrees. So we're kind of just listing all of those relationships. The measure of angle C plus the measure of angle D is 180 degrees. And lastly, D and A, the measure of angle D plus the measure of angle A equals 180 degrees. One last piece of information that we're going to look at is our diagonals. And I kind of referenced this a little bit earlier. And diagonals are the segments that connect the opposite angles or vertexes. So I'm going to draw one more parallelogram. Oops, and we'll label this one again A, B, C, D. And now in a parallelogram, our diagonals are going to go the opposite vertexes. So we're going to be looking at from A to C and then from D to B. Now, in a parallelogram, these diagonals bisect each other. So that means this, we'll label the where they intersect, right there in the center, it bisects each other. So that means this is the same as this. And AE is congruent to EC. So let's list that out. AE is congruent to EC, and DE is congruent to EB. Remember, bisect means that it kind of cuts it in half. So all of this information we can use to solve problems. So let's look at 2 different types of problems that you can see that go along with this. These are our examples. The first one, we're going to find the measure of angle A, the measure of angle D. We're going to solve for x. And we're going to find the segment length AB. So first we're going to draw our parallelogram. They don't always have to look just like this, but our examples, they do. And I'm going to tell you that it's a parallelogram by putting those little symbols in. I'm going to tell you this angle right here is 127 degrees. And this segment we're going to say is x plus 2. And this one's 2x minus 3. So now we're looking for a few things. We're looking for angle A. We're looking for angle D. We have to solve for x, and we want to find this length right here. So those are the things that we need to do. Now, actually, the first thing that I think the easiest one to find is going to be the measure of angle D. Remember, we said opposite angles are congruent. So the measure of angle D, we'll just kind of do this, is 127 degrees because they're the opposite. Across from each other are the same. Now, to find the measure of angle A, we actually have two ways now because the consecutive angles have to add up to 180 degrees. So A and B are consecutive, or A and D. We know as D is now 127, so it's the same problem either way. But so to find the measure of angle A, we add our 127 degrees, and that's going to equal 180. So we subtract 127 from both sides. The measure of angle A is equal to 180 minus 127 is 53 degrees. So this is 53 degrees. Now we're going to solve for x. Now to solve for x, I have this is x plus 2, and this is 2x minus 3. So they're opposite sides. Remember, opposite sides of parallelogram are equal. So we do x, or congruent, plus 2 equals 2x minus 3. We want to get our x's together. They're on opposite sides of the equal sign. So we have to subtract this x from both sides. Those go away. 2 is equal to 2x minus 1x, or x. Remember, it's just an x or 1x, minus 3. Add 3 to both sides. X is equal to 5. Now that we know that x is 5, we can find AB, which is x plus 2. We know x is 5, so 5 plus 2, AB is 7 units, or whatever we have. One more example that we're going to look at. We're going to solve for, or find, x and y. We'll draw our parallelogram this way this time. Switch it up a little bit. We have Q, we have R, S, and P. Now we're going to look at diagonals this time. So remember, we said diagonals bisect each other. So that means this length is going to be the same as this length. This length is the same as this length. So I'm going to put in some, we're going to say this is 2x plus 3. This is x plus 5. And then I'll do, this is 4y plus 5. And this is 2y plus 15. So we actually have two different problems that we have to work on because we have to solve for x and for y. Now to solve for x, we can only do things that are x's. But remember, the diagonals bisect. So that says this is congruent to this. So we're going to set that up. 2x plus 3 is congruent or equal to x plus 5. And now, like we just did before, we're going to solve for x. So I like to always move the smaller x. And they're on opposite sides, so those go away. 2x minus 1x is just x plus 3 equals 5. We're going to subtract 3 from both sides. We get x is equal to 5 minus 3, which is 2. We can check it. 2 times 2 is 4. 4 plus 3 is 7. 2 plus 5 is 7. So that works out. Now to find y, again, these are their bisectors. So that means they are congruent. So we'll set that one up. We have 4y plus 5 equals 2y plus 15. Again, I want to move, we have opposite sides, so I want to move the smaller y value. You don't have to, but it generally deals with less negatives that way, and negatives sometimes get confusing. Those go away. 4y minus 2y is 2y. We still have our plus 5 equals 15. We got to get y all by itself, so we're going to subtract 5 from both sides. Those go away. 2y equals 15 minus 5 is 10. Divide both sides by 2. We get y is equal to 5. Again, we can check that. 5 times 4 is 20. 20 plus 5 is 25. 2 times 5 is 10. 10 plus 15 is 25. So that shows that those values are the same. This concludes our notes for today. And you have your assignment on Schoology that goes along with this.